Hello students, today we deal with probability, basics of probability. There are some basic terms and basic terminologies, basic notations of probability. In this lecture, we will study the basics, definitions, terminologies and basic notations of probability. So first of all, we start with set. A set is a well-defined collection of elements. A set is well-defined collection of elements. What do we mean by the well-defined collection? Well-defined collection means it is quite clear if we pick up any element from the universe. It is clear either it will belong to the set or it will not belong to the set. For example, if we have the set of vowels A, E, I, O, U, and we pick up one, we pick up one. If you pick up one and we see that is one is the element of the set, that is not, obviously not. One is quite clear that one is not the element of the set of vowels. If we pick up A from the universe, small a, so it is clear that A is the element of the set of vowels. So it means that the set of vowels is the well-defined collection of elements. So it is a set. Types of set, if you talk about the type of set, so first of all we discuss about the empty set. Empty set means a set without element. Empty set means a set without element. A set without elements, there is no element in this set. So for example, there is a set S which contains the element of type X, the set S which contains the element of type X, such that X is natural number. X is natural number. X is natural number and lie between 1 and 2. And lie between 1 and 2. So it is quite clear there is no natural number which is lie between 1 and 2. So the set S is nothing but the empty set. Now we proceed further. Finite set. A set is finite if it contains finite number of elements. If it contains finite number of elements. For example, 5 elements, 6 elements, 7 elements, 10 elements, 100, 1000, lakh, arab, harab, billions, millions. So if these elements are finite in number, then the set is said to be finite. Otherwise, infinite set. For example, the set S contains the element of type X. X lie between 1 and 10. That is 2, 3, 4, 5, 6, 7, 8, 9. So the set S is the finite set. Similarly, the set S is the finite set. It contains the five elements. Now, further, we proceed to the next set, next type of the set, infinite set. A set containing infinite number of elements is called a infinite set. For example, the set of natural number, which is given below, the set of real number. These are the examples of an infinite set. Subset. A set A, if A and B are two sets, such that every element of A belongs to B. That is, for all X belongs to A, implies X belongs to B. For all the elements of A are the part of B. It means what? If we see the geometrically, if it is the set B and it is the set A, obviously every element of A is the element of B. So the set A is said to be the subset of B. Subset of B. So mathematically, how we will show it? For all X belongs to A, it will implies X will belongs to B if A is a subset of B. Okay. For example, if we have the set A, and so there are subsets like phi empty set. Empty set is the subset of each and every set. Either it is empty itself or a non-empty set. Singleton set A, singleton set E, singleton set I, singleton set O, singleton set U, and the selection of two from these elements by the different ways. So these are all are the subsets of a set A. Okay. So if we say if we have the non-empty set A, non-empty set, it means that either there are at least one element in the set. So there are two subsets. Phi empty is always the part is always the subset of every set, and set itself. So these two subsets are known as improper subsets, and the rest one other than these improper subsets are said to be the proper subset of a set. So now we talk about the power set. What about the power set? Collection of all possible subsets of a set. If we have the set S, so how many possible subsets are there? So there will be 2 to the power n possible subsets. Uh, if cardinality means the number of element in the set. If the cardinality of a set is n, then the total number of subsets, subsets equals to 2 to the power n. So if the set S has 1, 2, 3 as elements, then the cardinality of S is nothing but 3, and the total number of subsets is nothing but 2 to the power 3, that is equals to 8. So the power set of S will contain the 8 subsets. Huh? Phi set itself, these are the improper subsets. These are improper subsets. Improper subsets. And the rest one are proper subsets. So these are 8 subsets in counting: 1, 2, 3, 4, 5, 6, 7. So these are possible subsets, and the collection of all these possible subsets is the power set, which is uh, given here. So union of two sets. Now we talk about the union of two sets, A and B. A union B A union B contains the elements of type X such that either X belongs to A or X belongs to B. For example, if we have the set A equals to 1, 2, 3, and set B has the element 3, 4, 5, then A union B 1, 2, 3, 4, 5. It will contain the element, if you see in the shaded part, yellow shaded part. So all these elements in the region, yellow shaded region, are the part of A union B. Okay, so A union B. Okay, fine. If we have the next example uh, for the set A, it will contain the element of type X such that X is the natural number, and set B, it contains the element of type B such that X is an integer. So what about A union B? So A union B will contain the element of type X, either it is a natural number or an integer. Similarly, we talk about the intersection of two sets A and B. So the common parts or the common elements from the set A and set B are the part of the intersection. Okay. So if you talk about the intersection of two sets, so it will contain the element of type X such that X belongs to A and B, such that X belongs to A and B. Fine. So it is the setted part. It is the setted part, and it is the part of A intersection B. For example, if we have these two sets, set A and B, A contains 1, 2, 3, 4, and B contains 3, 4, 6, 7 elements. So what about the A intersection B? A intersection B will contain the element 3, comma 4. Difference of two sets A and B. A minus B means that it will contain the element of type X such that X belongs to A, but X is not the part of B. Okay, X belongs to A, X is not the part of B. So it means the common part of A which belongs to B also will not consider in A minus B. Similarly, B minus A will contain the element of type X such that X belongs to B and X is not the part of A. So here is an example, A minus B and B minus A. So you can see the A minus B and B minus A. Okay. So symmetric difference of two sets A and B. It is denoted by A triangle B, A minus B union B minus A. Such that it contains the element of type X. Either X is the part of A only or X is the part of B only. Okay. So it is a geometrical interpretation of the symmetric difference of two sets A and B. Uh, these are some examples. If A contains the cell element 1 to 5, B contains 4, 5, 6, 7, then find a union B, a intersection B, a symmetric difference B, A minus B, B minus A. Okay. Uh, these are some basics, very basic definitions of the sets, which are used to discuss the probability in further sections. Okay. Now, here we will talk about the basic terminology about the probability. So, first of all, we will talk about the event. What is the event? What is the event? Actually, event is associated with an random experiment. Now, the question is that what is the random experiment? Any experiment happening under uncertain situations. Any experiment, any experiment, okay? Any experiment happening it is wrongly written here, happening under uncertain happening, okay? Now correcting the okay, happening under uncertain situation. There is no biasness, there is no certain situations. So if you are performing any experiment which is going to happen under uncertain situation, comes in your mind is an event. Any question that we ask with regard to the random experiment is an event. For example, if we are throwing a toss, so this experiment is happening and there is no situations. So either the tail will come or a head will come. These two questions will come in your mind. So obviously these are two events. These are two events. Okay. For example, uh, results of tossing a coin, result of tossing a coin, result of throwing a dice, result of drawing a card from a pack of 52 cards are random events or random experiments. Okay, this is the example of random events and random experiments. Okay, now the question is there, what about the elementary events? Suppose that we have conducted a random experiment. It is completely defined when we know all the possible outcomes. If we are going to conduct a random experiment, it is completely defined if we know all the experiment. For example, अगर मान लीजिए हमें सारे outcomes पता है possible उसका, तो वो एलिमेंट्री इवेंट्स कहलाते हैं. अगर हम उसके सारे आउटकम्स नहीं पता है तो वो एलिमेंट्री इवेंट्स नहीं कहलाएंगे ना. For example, a dice, if you are throwing a dice, then one will come, two will come, three will come, four will come. So we know all the possible outcomes. So these are known as the elementary events. For example, a dice is thrown, the appearance of any number, that is 1, 2, 3, 4, 5, 6, is an elementary event. So these are the elementary events. This is the example of elementary events. What about the sample space? Collection of all elementary events, all possible elementary events. Every experiment associated with the events, elementary events. So collection of all these elementary events is nothing but the sample space, is known as the sample space. For example, if we have e1, e2, e3, e4 up to en, if we have n number of elementary events, then the sample space is e1 comma e2 comma e3 comma e4 up to en. For example, we will discuss this with example. If we toss a coin, so either there are two elementary events, that is tail will come, and second one is head will come. So what about the sample space? Sample space is nothing but head and tail. There are two, head and tails. It is the simple space. If we toss two coins simultaneously, so what about the elementary events? A1 head will come at the first toss, first coins, tail will come at the second. So similarly, these all are the possible elementary events. There are four possible elementary events. So the sample space is given here. Okay. And in the next example, if we toss the three coins simultaneously, then these are the eight possible outcomes which comes in your mind. That means there are eight elementary events are there. The associated simple space is here. Okay, fine. The next example is the two balls are to be drawn simultaneously from the set of three red and two white balls. Here the white balls are noted by the yellow ones, yellow colors and the red. Okay, fine. Find the simple space. So if we have the three balls R1, R2, R3, red balls, and W1 and W2 are denoted as the white balls, then the two balls are drawing from a set. So what possible outcomes may occur here? Even the red one, R1, R2 balls, both the balls are red, R1 and R2 may occur. So there are 10 possible outcomes. So we have this as a simple space. Okay. Sure events. Now we are further going to discuss some other terminologies of probabilities. We are dealing here with the sure event, sure event, universal event. Sure means event which will be happen. Okay, for example, if we are tossing a coin, and I'm saying that event is either it is head or tail. Either it is head or tail. Obviously, there are only two outcomes. Either tail will come or head will come. If you consider it as an event, so it is a sure event. If I ask that head will come, so then it is not the sure event. Okay. So a simple space of an experiment is the set of all possible outcomes. Since a set is also a subset of itself, then S can also be conducted as representing an event associated with the experiment. Now, since every outcome belongs to S, the event represented by S always occurs. Therefore, the events represented by S is called a sure event. Similarly, the impossible event, which is not going to happen anytime. Impossible event, for example, if in terms of mathematics we denote it by the set phi, there is no element, there is no elementary event. Okay, for example, two dice are thrown. Number one, the sum of two faces is always greater than or equal to 2. Obviously, obviously, it will always happen because at the faces of the dices are have at the least number is one, both one. So this event is the sure event. It will happen always. The sum of two faces, second one, the sum of two faces is always greater than 12. It will not happen in time. It is an impossible event. Equally likely events. The events are known as by its rank, equally likely. Let S be the sample space of a random experiment if all the elementary events of S have the same chance of occurring. Have the same chance of occurring. Okay, just note this line. Had the same chance of occurring. Then the events are said to be equally likely events. Mutually exclusive events. Consider the examples of throwing two dice simultaneously and the sum of the two numbers is noted. And here we are going to define the two events, events A and B. Events A, the sum of two numbers appearing on the dice is less than or equals to 4. And the event B, the sum of two numbers appearing on the dice is greater than 9, is greater than 9. So if we see the possible outcomes, E1 associated with the event A, E2 associated with the event B. So E1 will contain the outcome 2, 3, 4. The sum of two numbers appearing on the dice is less than or equals to 4. That is 2, 3, 4. Similarly, the possible outcomes of the event B, E2, that is 10, 11, 12, okay, greater than 9. So if you see that the union of E1 and E2 is nothing but the S, the sample space, okay, such that E1 and E2 is empty. So if we have the two events of a simple space such that E1 intersection E2 is empty, then the event A and B are mutually exclusive event, are mutually exclusive. So in short, if we say that two events, if they have empty outcomes, empty outcomes, if there is no common outcomes in both the events, it means these two events are mutually exclusive. What do we mean by the mutually exhaustive? Exhaustive events. Exhaustive events. Okay. Here we study with the mutually exhaustive events. If we have the several events, several possible events of a simple space S, for example, here are denoted by A1, A2 to A. If the union of all these events is nothing but the simple space, okay, simple space, and all these events are mutually okay. I repeat the definitions again. If the union of all these events is a complete simple space, then these events are said to be mutually exhaustive events. And if the intersection of different events is empty, then the events are said to be mutually exclusive and mutually exhaustive events. Okay. So the combination of two events is it is the basic algebra of events. So here we are going to discuss some example. A coin is tossed to thrice. If event A denotes the number of heads each odd and B denotes the number of tails each odd, then find the cases favorable to A intersection B. Okay. So it is quite simple. The sample space is given here. The three toes are the three coins are tossed. Okay, so it is the required simple space, and the event A is nothing but the number of head is odd. The number of head is odd, and the event B number of tails is odd. So here we are writing the set A, event A, and the event B associated with this statement. So if we see that A intersection B, is nothing but the empty. The events A and B are mutually exclusive, and we know that A union B is equals to S. It means these two events are exhausting the sample space. It means this that A and B are mutually exclusive and mutually exhaustive events. A remark is given here since A intersection A bar is empty. Okay. The event A and its complement are mutually exclusive events. Now we are going to the definition of the probability of an event. Okay, and here we are going to enter in probability chapters after the discussing some basic notations and some basic terminologies of a probability. To every event in a random experiment, we attach a numerical number, a numerical value, which is called the probability. We denote the probabilities of the events A and B symbolically by P of A, PA, and PB respectively. So, what is the how we will define the probability of A? Number of elementary events favorable to E. E means the set of possible outcomes of A, of event A. Okay. So the number of elementary events favorable to E and the total number of equally likely elementary events. Okay. So it is the probability of A. And we know that the probability of impossible events is 0 and the probability of the simple space is always 1. And it is also quite clear the probability of A will be greater than equals to 0 and less than equals to 1. So here we are going to discuss an example. Three coins are tossed simultaneously. What is the probability that at least two tails occur? At least two tails occur. Three coins are tossed simultaneously. Okay, so here we can solve these questions very easily. If we talk about the solution, so what about the simple space? First of all, we will write here the simple space, and the simple space, we have the simple space. There should be the eight element T, H, H, and T, H, T, and T, T, H, and H, T, T, and H, H, T, and H, H. So how many element? Two, four, to six, and uh, H, T, H, and STT. STT is already here, and mm, TTH, TTH. So there are, I think these are eight. 1, 2, 3, 4, 5, 6, 7, 8. So there are eight elementary events. There are total number of eight elementary events. So what about the event A? Uh, A is what? There should be at least two tails occur. So how many outcomes? At least two tail occur. It means what? At least two tail occur. That is one and two. One, two, and three. Two tails occur and four. At least two tails occur. So one, two, three, four. So uh, THT and HTT and TTH and TST, STT, TTT. Okay, okay. So these are the favorable chances. These are the favorable chances, and these are the possible chances. So what about the probability of A? At least two. tails occurs. So favorable chances are 4 and the total chances are 8. That is 1 by 2. It is the final answer. Similarly, we have the next questions. What is the probability that a number selected from the numbers 1 to 20 is an even number? Okay. So here we are going to solve these questions. And if we talk about the total number of chances, total number of events, what is the probability that the number selected from the numbers is 1 to 20 is an even number? So the total chances is what? 20. Okay. The total chances equals to 20. And the favorable chances. And the favorable chances equals to corresponding to an even number, that is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. That is, it means 10. Then the of probability of an even number, okay, probability of an even number is nothing but the favorable chances divided by total chances, that is equals to 1 by 2. So these are some basics, some basic questions. Okay. Here we have result and the very basic result. If A and B are two mutually exclusive events of a random experiment, mutually exclusive events, it means there is no common. There is no common outcomes. There is no common elements in both the events A and B. Then the probability of A union B is nothing but the probability of A and probability of B. Okay. So similarly, here we can give a remark. If we have the k number of mutually exclusive events, then probability of A1 union A2 union up to AK is nothing but the probability of A1 plus probability of A2 up to probability of A. Okay. Now, here we are going to discuss the another one example. Throwing a dice. And the events are outcomes multiple of 2 and events be outcomes odd numbers, 2 dice are being thrown. Okay, so outcomes multiple of 2 means 2, 4, 6. Outcomes odd number means 1, 3, 5. Dice, throwing a dice. Okay, so these are possible outcomes. So obviously A intersection B is empty. Mutually exclusive events. These are mutually exclusive events. And A union B is complete sample space S. So it is what? Uh, these two are mutually exclusive and mutually exhaustive events. So if these are mutually exclusive events, then probability of A union B is what? Probability of A plus probability of B. So what about the probability of A? That is the outcomes multiple of 2. There are 3 favorable chances. There are 6 total chances. Then the probability of A is nothing but the 3 by 6. And the probability of B is nothing but the 3 by 6. That is equals to 1. Okay. So here we are going to deal with law of addition of probability. Law of addition of probability. If A and B are two events associated with a random experiment, then the probability of A union B is what? Probability of A plus probability of B minus probability of intersection. It means what? A and B here are two events. It doesn't mean that these are mutually exclusive. Okay, they may have some common outcomes too. So this is the formula of probability of A union B. Okay, now this is the example. There are some examples, and in these questions we are going to deal with the above definition. 2 dice are tossed once. Find the probability of getting an even number on the first dice or a total of 8 on the second. So there are two events. Event number A, event A, getting an even number on the first dice. So 2 1, 2 2, 2 3, 2 6 up to 2 6, 4 1, 4 2 up to 4 6. Similarly, 6 1, 6 2 up to 6 6. So there are 18 favorable or 18 elementary events in the 18 outcomes in the event A. Similarly, in the event B, the sum of total should be 8. That is 2, 6, 3, 5, 4, 4, 5, 3, and 6, 2. Then the number of possible outcomes, total possible outcomes, equals to 36. Then the probability A is nothing but the 18 by 36. That is 1 by 2. Probability of B is nothing but the 5 by 36. Then probability of A union B, probability of A plus probability of B minus probability of intersection B. So probability of intersection B is what? Here we will find the common in A and B, that is 2, 6, 4, 4, and 6, 2. It means that there are favorable, it means what? The first, uh, it means what? The first dice should have the even number, and the total of both the faces of the dice should be 8. Okay, so the probability of intersection B is nothing but the 3 by 36, because there are only 3 favorable chances, that is 1 by 12. Now probability of A union B, it is what? 1 by 2 plus 5 by 36 minus 1 by 12. Because the question is asked here, find the probability of getting an even number on the first dice, or a total number of 8, or a total number of 8. That means A union B. It is talking about the A union B. If here we have and in place of or, it means we are talking about the A intersection B. Okay, so it is quite simple questions. Now the next question is that uh, from a pack of well shuffled card, one card is drawn. Find the probability that this card either a king or an egg. Okay, so we have the total cards. How many total cards are there? We have the total cards, 52. 52 total cards are there. Okay, and the king, how many kings are there? There are 4 kings. How many egg are there? 4 egg are. Okay, so the probability of an event A, that is there should be king, that is 4 by 52, that is 1 by 13, and the probability of B, that there should be egg, 4 by 52, that is 1 by 13. So probability of both the events are mutually exclusive events. There is no comma. There is no comma. Okay. So probability of A union B is nothing but the probability of A and probability of B. So 1 by 13 plus 1 by 13 is nothing but the 2 by 13. And the second question answer. What is the second question? From a pack of well shuffled cards, 4 cards are drawn. Find the probability that there are 2 hearts and 2 diamonds. There are 2 hearts and 2 diamonds. The total chances 52C4. Okay, NCR means the total number of combinations. Okay, NCR, that is n factorial upon r factorial n minus r factorial. So there are total 52 cards, and we need to draw the 4 cards. So the total chances are 52C4. And the probability of a 2 cards are from hearts. So how many hearts, total hearts card are there? 13 hearts card are there. So the favorable chances of 13C2. You know? And the probability of 2 cards are from diamonds. Then the favorable chance 13C2. Okay. And the probability of the 2 cards are from hearts, and the 2 cards are from diamonds. And the 2 cards. So 13C2 into 13C2 divided by 52C4 is the final answer. And the next question is quite interesting questions. A bag contains 4 red and 3 black balls. Here, 7 number of balls are there. A second bag contains 2 red and 4 black balls are there. One bag is selected at random. From the selected bag, one ball is drawn. Find the probability then the ball drawn is red. Okay, so the main thing is that first you need to select a bag. So how many ways you can select this bag? Okay, now if you talk about we have two bags are there. A bag contains four and three. So for example, we have two bag A and bag B. So bag A contains four red and three black. Okay, and the second bag contains two red plus four black. One bag is selected, so there are only two bags. So how many ways we can select? Okay, that is one by two. That is one by two. There should be a solution, I think, here. If there is no, okay, there is no solution here. Okay, one ball is drawn from at random from the selected bag. One ball is drawn. So either it is this, it will be the bag A or two. Okay, so how many chances to select a bag? That is, wait a minute. That is one by two. Okay, that is one by two for the set A. For the set A. Okay, and find the probability that the ball drawn is red. Okay, and how many red ball are there in the bag A? Two red balls. No. Four red balls are there in the bag A. So the favorable chance is four, and total balls are there is seven. Okay, but there may be, or it may happen that the second bag will come. That is one by two. Okay, so how many red balls? Two, six. Okay, that's it's cancel out. So what is the final answer? 4 by 14 and plus 1 by 6. Now find, solve it and find the final answer. So similarly, where we have the next example, ABC are mutually exclusive and mutually exhaustive events, mutually exclusive and mutually exhaustive events associated with the random experiment, and the probability of B is nothing but the zero point 0.6 and zero point 0.6 into probability of A, and probability of C is nothing but the zero point 0.2 into probability of A, then find probability of A. So it is quite mutually exclusive and mutually exhaustive events are there. Okay, so what does it mean? Then probability of A union B union C is equals to, uh, if it is mutually exhaustive, these events are mutually exhaustive. It means these will generate complete sample space, and the probability of the complete sample space is nothing but the one. Now the probability of A, because these are mutually exclusive events, then we can write probability of A, probability of B, and then probability of C is equals to 1. So here probability of A, simple here. And what about the probability of B? That is zero point 0.6 probability of A. What about the probability of C? 0.2 probability of A equals to 1. Okay, equals to 1. So it is, what about it? So it is a total 1.8 probability of A equals to 1. That is, this implies that probability of A is nothing but the 1 upon 1.8. Okay, 1 upon 1.8. So it is quite simple questions. Okay, now the next questions. Next question is very simple. The probability that at least one of the events A and B occur is 0.8, and the probability that the events occur simultaneously is 0.25. Find the probability of A bar and plus probability of B bar. So probability of union B, that is at least one occur, that is either A or B. That is, it means A union B. So probability of A union B is given 0.8, and both the events occur simultaneously together. That is A and B. The probability of intersection B is 0.25. Now the probability of A union B. Probability of A union B is equals to what? The law of addition, the probability law of addition. Here we are using the probability of the addition, that is probability of A union B is nothing but the probability of A, probability of B minus probability of intersection B. So probability of A is what? 1 minus probability of not A plus probability of B is what? 1 minus probability of not B, then minus probability of intersection. So here we can conclude the probability of A bar plus probability of E bar is given simply. Okay, 0.95. It is a very good questions too. I love these questions. A bag contains 6 reds and 5 blue balls, and another bag contains 5 red and 8 blue balls. A ball is drawn from the first bag, and without seeing the color, it put in the second bag. A ball is then drawn from the second bag. Find the probability that the ball drawn is blue in color. एक बैग के अंदर 6 बॉल रेड हैं और 5 बॉल ब्लू हैं, और दूसरे बैग के अंदर 5 रेड हैं और 8 ब्लू बॉल है। एक बैग ड्रॉ किया जाता है, एक बॉल ड्रॉ की जाती है एक बैग से और वो दूसरे में रख दी जाती है बिना कलर उसका देखे हुए। तो वो कह रहा कि सेकंड बैग से एक बॉल अगर हम ड्रॉ करेंगे क्या प्रोबेबिलिटी होगी कि वो बॉल ब्लू हो। तो पहली तो बात कि 2 बैग हैं, पहले तो 2 बैग में से एक बैग आपको सिलेक्ट करना है। अगर बैग ए आपने सिलेक्ट किया जिसमें 6 रेड और 5 ब्लू बॉल है, तो 1/2 इसकी तो होगी पे कि ए आपने 2 बैग में से एक सिलेक्ट किया तो 1/2 प्रोबेबिलिटी तो ये होगी आपकी। ये करने के बाद अब एक बॉल ड्रॉ करनी है इसमें से, है ना, एक बॉल ड्रॉ करनी है। ये इसका सोल्यूशन है यहाँ पे, है ना। अ रेड बॉल, सॉरी पहले बैग के सिलेक्शन की बात ही नहीं हो रही इसलिए 1/2 की बात ही नहीं करेंगे। यहाँ बॉल की सिलेक्शन की बात होती है। तो 2 केस बनेंगे कि एक रेड बॉल आपने ड्रॉ किया फ्रॉम बैग ए, और बैग ए से ड्रॉ करने की के लिए प्रोबेबिलिटी होगी आपके पास 6/11, और फिर आपने इसे बैग बी में रख दिया। अब बैग बी में रखने के बाद बॉल्स होगी आपके पास 14, 6 रेड एंड 8 ब्लू। तो पहला केस ये था कि जो आपने पहले बैग से बॉल निकाली वो रेड है ना, और रेड है तो आपने यहाँ पे P1 ब्लू बॉल होने की प्रोबेबिलिटी आपने निकाली, यानी कि 6/11 इंटू 8/14। फिर दूसरा केस क्या बनेगा आपके पास कि जो बॉल आपने निकाली वो ब्लू हो, जो बॉल आपने निकाली ब्लू हो और उसको आपने सेकंड बैग में रख दिया, देन प्रोबेबिलिटी ऑफ A is 5/11 and the probability of B2 is. So the total probability in both the cases nothing but the 48 upon 1 154 and plus 45 upon 154. So these are the basic questions. So these are the quite simple questions. I think you guys will enjoy all these questions beautifully. And in the next section, we will study the conditional probability. If we have the two events A and B, so B already occurred, so what is the probability of A? If B already occurred, condition is that the B has occurred, and the probability of A with B is nothing but the probability of A and B and probability of B. Okay. Multiplication law of probability. Let probability A B occurred and the probability of A, and probability of A already occurred of B denoted the condition probability of A when B occurred and of B when A has occurred respectively. Then the probability of intersection B is nothing but the probability of B into probability of A intersection A oblique B, and the probability of A the probability of B oblique A. फॉर एग्जाम्पल इफ वी टॉक अबाउट द कंडीशन प्रोबेबिलिटी को आप इस तरह की दे सकते हैं कि दो इवेंट है कि पहले ए हो चुकी है बाद में दूसरी करनी है ना कंडीशन है इसमें कि पहले बी हो जाए तब ए होने की क्या कंडीशन है क्या चांसेस हैं जैसे कि टू इवेंट्स है ए एंड बी कि प्रोबेबिलिटी ऑफ ए के 0.5 चांस है प्रोबेबिलिटी ऑफ बी के 0.6 चांस है और दोनों के यूनियन के 0.8 चांस है तो कंडीशन प्रोबेबिलिटी निकालनी है तो सिंपल आप फॉर्मूला लगा देंगे यहाँ पे और ये सिंपल कैलकुलेट हो जाएगी देयर इज नो लॉजिक इट इज दिस क्वेश्चन बेस्ड टोटली बेस्ड ऑन फॉर्मूला दिस क्वेश्चन इज आल्सो टोटली बेस्ड ऑन फॉर्मूला और अगर हम इस क्वेश्चन की बात करें ये थोड़ा एनालिटिकल सवाल है अ डाइस इज थ्रोन ट्वाइस एक डाइस को दो बार आपने थ्रो किया एंड द सम ऑफ द नंबर्स अपीयरिंग इज नोटेड टू बी 8 जो सम ऑफ द नंबर्स है अपीयरिंग इज नोटेड टू बी 8 व्हाट इज द कंडीशनल प्रोबेबिलिटी दैट द नंबर 5 अपीयर एट लीस्ट वंस 5 अब देखो इसमें कंडीशन कहां पे लगा दी कि क्या कंडीशन प्रोबेबिलिटी क्या है व्हाट इज द कंडीशनल प्रोबेबिलिटी दैट द नंबर 5 हैज अपीयर्ड एट लीस्ट वन कि कम से कम एक बार तो नंबर ऑफ 5 आ चुका होगा तो ये कंडीशन लगा दी कि साहब 5 तो आ गया अब सम 8 आए उसी का प्रोबेबिलिटी क्या है तो यहाँ पे कंडीशन है ओके सो ए को आपने माना कि 5 हैज अपीयर्ड एट लीस्ट वंस बी में माना दिस सम ऑफ द नंबर्स इज नोटेड टू बी तो अगर आउटकम्स की बात करें कि ए में कौन कौन से आउटकम होंगे 5 ऑलरेडी आ चुका तो उसके लिए टोटल आउटकम्स आपके पास स्क्रीन पे दिए हुए हैं है ना और बी क्या है आपके पास कि 5 ए में क्या आपके पास 5 हैज अपीयर्ड एटलीस्ट वन कि 5 कम से कम एक बार आया हो चाहे पहली पे आया हो दूसरी पे आया हो दोनों पे आया हो है ना और बी में क्या है आपके पास कि सम 8 हो ठीक है तो 5 पहले आ चुका है फिर सम 8 थे तो 5 और 3 8 3 5 8 अच्छा सम 8 आई यानी कि बी के अंदर ये टोटल नंबर ऑफ चांसेस रहेंगे आपके पास तो इसे प्रोबेबिलिटी ऑफ ए प्रोबेबिलिटी ऑफ बी निकाल लेंगे आप यहाँ से टोटल आउटकम आपको पता है कि 36 होते हैं लेकिन बात कर रहा है कि वो बी आ जाए पहले 5 आ जाए और फिर समेट हो तो यानी कि इन दोनों के इंटरसेक्शन की बात कर रहा है कि पहले में 5 आ जाए पहले 5 आ जाए एक पे 5 आ जाए कम से कम है ना जो आप देखें कि व्हाट इज द कंडीशनल प्रोबेबिलिटी दैट द नंबर 5 हैज अपीयर्ड एट लीस्ट वंस कि कम से कम 5 एक पे आ गया तो ठीक है ये आपके पास टोटल चांसेस क्या क्या बनेंगे इसके वो बनेंगे 5 3 3 5 जो दोनों में कॉमन और 6 5 ठीक है 6 5 आई थिंक 6 5 not available 6 5 no 6 5 is not the part of intersection B there is only two elements 5 3 and 3 5 so the probability of intersection B is nothing but the 2 by 36 okay so probability of B that A already occurred it means the conditional probability here is the formula simple formula now compute all the possible values and then find the answer okay so here uh, we have discussed the conditional probability with the very good examples and so in the next class in the next lecture we will discuss the some other definitions of the probability just like the independent event and Bayes theorem, total law of probability. So, guys, see you in the next class and the next lecture. Thank you very much. If you have any doubt, then you can ask me freely any question. We are free to ask any question.